What if the Milky Way is so small that our entire view of the cosmos is wrong? As you read these words, you exist within a cosmic illusion so complete that you don't even realize you're trapped in it. For generations, astronomers have believed they were mapping the true shape of the universe. They pointed telescopes at the sky, traced faint spirals of distant galaxies, measured the glow of ancient radiation, and thought each discovery pushed humanity closer to a complete understanding of reality. But what if every one of these measurements, every diagram, every carefully plotted observation is built on a foundation that is fundamentally wrong? What if the very framework of our cosmic perspective, the belief that the Milky Way is vast and monumental, is nothing more than a small local misunderstanding? And what if the universe we think we're seeing is no more accurate than a shadow flickering on a distant wall? Imagine the Milky Way as we believe it is, a sprawling spiral city containing hundreds of billions of stars and stretching 100,000 light-years from edge to edge. We picture ourselves drifting inside a colossal stellar metropolis, surrounded by swirling arms of gas, dust, and star clusters. It feels enormous because we are small. It feels infinite because our senses are limited. But now imagine something radically different. Imagine that the Milky Way is not a galaxy in any traditional sense, but something far, far smaller. So small that calling it a galaxy is like calling a grain of pollen a planet. Imagine that every measurement we've ever taken was done inside an electromagnetic bubble so tiny compared to the larger universe that the very concept of the observable cosmos is simply the interior physics of a microscopic region. Think of shrinking the entire Milky Way until it becomes smaller than a speck of dust, and then imagine placing that speck inside a structure so vast, so dimensionally complex, that our entire observable universe would be indistinguishable from a molecule inside its architecture. In this vision, everything, redshift, cosmic expansion, background radiation, dark matter, dark energy, would not be describing the universe as a whole, but only the behavior of the tiny domain in which we exist. The universe we think we understand might be nothing more than the microenvironment of a much grander reality. To even begin considering this possibility, you have to step outside human intuition. The human brain evolved to detect predators, gauge distances, and navigate landscapes measured in meters, not megaparsecs. It was never built to process numbers like 100 trillion or ideas like curved spacetime. Our mental wiring is not suited for cosmic thinking. When we look at the universe, we see it through instruments limited to our own electromagnetic spectrum, our own quantum rules, and our own physical constraints. We believe the Milky Way is a giant because our senses and tools are tiny. But what if this sense of scale is an illusion created by our confinement? Consider, for example, the possibility that our galaxy is not a galaxy at all, but a localized electromagnetic domain inside a medium where the rules of physics are drastically different. Beyond the edges of this domain, our type of light might not propagate, our particles might not exist, our measurements might collapse. If this is the case, then our universe is simply the region where our specific version of physics works. Everything beyond it might be dark not because it's empty, but because our tools cannot detect the forces at play there. If you lived inside a microscopic droplet floating in a vast ocean, but only the droplet emitted light, you would conclude the droplet was the entire universe. You would observe expansion at the edges and invent theories to explain why everything seemed to accelerate outward. But the truth would be painfully simple. You never saw the ocean at all. You only ever saw the droplet. That droplet would be our Milky Way. This raises a terrifying question. How small is our droplet? Astronomers estimate that the Milky Way contains around 400 billion stars, but that number relies on the assumption that stars must emit light detectable through our physics. What if most stars do not emit in our detectable spectra? What if most matter does not interact with our forces? Dark matter and dark energy might not be mysterious components of our universe, but gravitational fingerprints of structures outside our bubble. We could be misinterpreting the behavior of the larger medium as internal cosmic phenomena. Everything we think we know might be nothing more than the distorted shadows of an unseen environment. Now imagine that our galaxy sits inside a filament of the so-called cosmic web, not as a galaxy, but as a structure so small it is equivalent to a quantum particle. In this interpretation, what we call galaxy clusters might be microscopic turbulence within a higher dimensional fluid. The largest structures we have ever detected, the Sloan Great Wall, the Hercules Corona Borealis Great Wall, could be nothing more than ripples or imperfections on a surface trillions of times larger. If so, then every cosmic measurement we have ever made is not describing the universe, but merely detailing the interior forces acting on a speck. The implications are staggering. What if the laws of physics we consider universal are merely local conditions inside our bubble? Imagine an ant living inside a sheet of circuitry. It could measure voltages, map out the paths of electric flow, and build a complete physics of its observed world. But it would never understand computers, software, or the digital universe operating across that circuitry. It would never know what existed above or outside. The ant's universe would simply be the hardware beneath its feet. In the same way, our universe might be nothing more than a tiny region of a hypercosmic superstructure whose nature we cannot perceive. Even the most cherished evidence of our cosmic origin might be misinterpreted. What we call the cosmic microwave background might not be the afterglow of a Big Bang, but the thermal boundary of our region, the faint hum of interaction with a larger system outside our physics. What we call cosmic expansion might not be the universe stretching, but our bubble growing within a larger medium. What we call dark energy might be nothing more than external pressure acting on the membrane of our droplet. In this scenario, the Big Bang is not the birth of the universe. It is the nucleation of a bubble in a cosmic ocean. This leads to a deeply unsettling idea. Everything we think is large is small, and everything we think is fundamental is emergent. Stars could be atoms. Galaxies could be molecules. Galaxy clusters could be chemical structures. Cosmic filaments could be polymer chains. Superclusters could be organelles. The observable universe could be a single cell inside a being so vast that our entire cosmic history unfolds within a microscopic corner of its existence. And what about consciousness? If reality operates on infinite levels of scale, then intelligence might emerge at all of them. Vast cosmic beings might exist with thoughts that span millions of years. Their neural structures might be built from galaxy-sized regions. Their awareness might ripple through dimensions far beyond our comprehension. Our entire civilization might be invisible to them, not because we are unimportant, but because we exist on a scale many layers below their perception. The most provocative idea remains this: what if humanity's most advanced observations, the deepest images of the cosmos, the faintest traces of ancient radiation, are not views of the universe, but illusions produced by the boundary of our microscopic domain? What if we have never truly seen the cosmos at all? What if everything we know is just the interior curvature of a tiny structure in an unfathomably larger reality? This is the question that should shake you at your core. What if the Milky Way is so small that our entire view of the cosmos is wrong? If the frightening possibility is true, that the Milky Way is not an immense stellar metropolis, but a microscopic element embedded inside a structure so vast we cannot comprehend it, then every assumption we've ever made about distance, scale, and physical law must be reconsidered. And when you begin peeling back the layers of what this implication truly means, you're forced into a disorienting realization. Humanity may not merely misunderstand the universe, we may have entirely misidentified the category of thing the universe actually is. Our telescopes, our maps, our theories, our cosmological principles, they all operate under the premise that the universe is a single, coherent, contiguous space governed by uniform laws. But what if that assumption is the biggest illusion of all? What if the cosmos is not a universe, but a compartment? Not a grand totality, but a chamber? Not the final structure, but the interior of something far more complex, far more layered, and far more alien than anything we've ever dared to consider. Imagine, for a moment, that our universe resembles a biological cell. Inside that cell, particles rush around like proteins, stars ignite like mitochondria, and galaxies swirl like molecular complexes. But the cell itself would be one among countless others embedded in a tissue of incomprehensible scale. Each universe cell would be isolated by its own boundary conditions, its version of physics, its constants, its forces. Our microscopes, telescopes, and equations would never detect the outer tissue. We would be immured within the membrane, blind to the true architecture of the whole. This possibility is not pseudoscience or fantasy. It arises naturally when you consider that all our observations are filtered through human limitations. Not limitations of technology, but of dimensional access. We can only see what our physics allows us to see. We can only measure what our particles can interact with. If our entire domain is isolated by a boundary condition that prevents outward detection, then our cosmic horizon, 46.5 billion light-years, is not the edge of the universe. It is simply the limit of our visibility inside a sealed system. Now consider the unsettling implications of this sealed system model. If our universe is a compartment, then its apparent expansion might not reflect a universal expansion at all. It might reflect pressure, tension, or distortion from the outer medium. Cosmic acceleration might not be caused by dark energy, but by the mechanics of the environment outside our boundary. The boundary could be stretching, not because space is expanding, but because forces beyond it are pulling, compressing, or reacting. Our measurements would interpret the expansion as internal, because we have no reference point outside. In the same way, an ant trapped inside a balloon would interpret the balloon's inflation as the expansion of its entire world. But the cause of that expansion would lie far outside the ant's understanding. This leads to a far more disturbing thought. What if cosmic background radiation is not ancient light from the beginning of time, but the thermal signature of the boundary itself? Instead of observing the leftover heat of a Big Bang, we might be detecting the faint glow of interactions occurring at the membrane of our domain. In this scenario, recombination never happened because a Big Bang never happened. Our origin event would not be an explosion, but a formation, a condensation, a crystallization, a nucleation. Space did not burst into existence. It cooled into existence. Light did not suddenly become free. Our domain became transparent to light once the boundary stabilized. Every cosmological story we tell, from inflation to nucleosynthesis to expansion, could be nothing more than internal dynamics, misinterpreted as universal truths. If the Milky Way is microscopic, then our domain is microscopic, and the universe we think we inhabit is simply a tiny interior region of a structure whose true scale dwarfs everything we've ever imagined. In this broader architecture, matter might clump into megastructures whose sizes exceed our entire observable cosmos. Forces might operate at scales that render gravity negligible. The enormous cosmic voids we observe might not be voids at all, but corridors, channels, or interstitial spaces within a colossal framework. Our cosmic web might be nothing more than the scaffold of a vastly larger lattice. One of the most profound consequences of this model is the reinterpretation of dark matter. Scientists estimate that 85% of all matter in the universe is dark, meaning it does not interact with our electromagnetic forces. But what if dark matter is not matter as we understand it? What if it is simply the influence of structures outside our domain pressing inward on our enclosed interior? Picture a trampoline with objects placed underneath the fabric. A small marble on the surface would feel distortions caused by those unseen objects below. It might interpret those distortions as invisible masses interacting with it. But the marble's dark matter would not be matter at all. It would be external structure. Every galaxy rotation curve, every gravitational lensing event, every observation of mass discrepancy might be nothing more than the interior responding to forces beyond its boundary. This model also forces us to rethink time. If our domain is microscopic inside a larger framework, then our timescale might be microscopic as well. The entire history of the universe, 13.8 billion years, might correspond to less than a moment in the outer architecture. To the greater structure, our cosmic evolution, from the first atoms to the rise of stars to the birth of consciousness, might unfold in the blink of an eye. Our entire cosmic past might not even register as a measurable event at that scale. If enormous cosmic intelligences exist outside our domain, they might perceive the evolution of our universe the way we perceive the vibration of a molecule, a flicker, a whisper, a brief fluctuation in a system they barely notice. But the reverse is also true. If the Milky Way is microscopic within a larger hierarchy, then structures below us might be equally complex. Subatomic particles could contain universes. Quantum fluctuations could be miniature cosmic events. The vacuum of space could be teeming with universes inside universes inside universes, stacked infinitely in both directions. Our physics would never reveal these layers, because each layer operates under its own rules. Our instruments would be incapable of detecting them, just as a bacterium cannot detect a star. Scale is not merely relative, scale is ontological. It defines what can exist at each level of reality. And if scale defines existence, then consciousness might be scale-aware only within its own domain. Humans perceive the macroscopic world because our bodies evolved at that scale. We cannot perceive atoms or galaxies directly. We require tools. But what if consciousness itself exists at multiple layers? What if the universe above us contains minds that experience thoughts lasting millions of years? What if the universe below us contains minds that experience lifetimes in trillionths of a second? Each would inhabit a scale of consciousness so foreign that communication becomes impossible. Humanity would not merely be isolated by distance, we would be isolated by dimensional scale. This dimensional isolation might explain another mystery, the Great Silence. The universe appears teeming with planets, stars, and galaxies, yet absent of detectable civilizations. But if civilizations exist at scales above or below us, we would never detect them. If we are microscopic, then our entire observable domain is a quiet corner of a larger structure, irrelevant to the larger intelligences operating at grander scales. They might not even realize we exist, or worse, they might realize, but our scale makes us as imperceptible to them as individual atoms are to us. Now consider cosmic expansion through this lens. If the Milky Way is microscopic inside a dynamic outer medium, then the expansion we observe could be a local reaction to processes occurring outside our domain. The accelerating expansion might not be universal. It might simply be the stretching of the boundary membrane as forces beyond it evolve. The disappearance of distant galaxies could be an artifact of the membrane's deformation. In this interpretation, cosmic acceleration is not a mystery. It is a side effect. If this is true, then the future of our universe becomes equally uncertain. If the external medium compresses, our domain might shrink. If the external forces tear, our domain might rupture. If the larger structure reorganizes, our entire universe might vanish, not as a collapse or explosion, but as a bubble dissolving inside a liquid. The end of the universe might not be heat death or a big rip. It might simply be dissolution, a quiet, unnoticed disappearance inside a cosmos that never realized we were here. This possibility, as terrifying as it is, also reveals something extraordinary. If the Milky Way is microscopic, and if our universe is only one compartment in a much larger hierarchy, then the existence of humanity is not trivial. We are the internal self-awareness of a tiny domain, a bubble developing consciousness, a speck learning to contemplate the ocean. Our significance is not diminished by scale, it is defined by insight. The cosmos may be far larger and far stranger than we ever imagined. But the fact that we can imagine it at all is evidence that consciousness is not limited by scale. If our galaxy is microscopic inside a far larger architecture, then the next question grows unavoidable. What is the larger structure actually made of? Is it material in any sense we understand? Or is matter, as we know it, merely a local expression of something that behaves completely differently at grander scales? When you begin probing this question, the foundations of cosmology start to tremble. Because if scale itself determines what kinds of structures can exist, then matter might merely be a scale-dependent effect, something that appears solid only within the narrow parameters of our domain. In a larger universe, solidity might not exist, forces might not exist, time might not exist, at least not as a steady flow. Everything we take for granted could be local physics masquerading as universal truth. Consider how electrons orbit atomic nuclei, not as planets orbit their stars, but as probability clouds, smeared across space in patterns that do not resemble classical orbits at all. Now consider how stars orbit galactic centers, not as electrons do, but in predictable paths shaped by gravity. Two levels of reality, two completely different behaviors, yet both called matter. What if these two levels are only adjacent steps in an infinite hierarchy? What if above galaxies, there exist structures even larger that obey laws as radically different from gravity as gravity is from quantum mechanics? Our physics seamlessly describes small to mid scales, but utterly breaks down when stretching too far in either direction. The mathematics fractures, the intuitions collapse, the rules contradict. Scientists try to unify physics and fail, not because they lack the right equations, but because they assume everything belongs to the same physical level. But what if each level has its own physics? What if the universe is not one reality, but a nesting of realities, each governed by distinct rules? In that scenario, our galaxy's behavior is not universal physics, it is local physics. And our attempts to merge gravity with quantum mechanics are like trying to merge the rules of ocean waves with the rules of molecular vibration. Both describe water, but at entirely different scales. No single equation unifies them naturally, because water is a layered structure. Reality might be the same. Now imagine this at cosmic magnitudes. Perhaps what we call space-time is the water of our scale, fluid-like, dynamic, flexible, yet only one of many structural phases of existence. Above our scale, space might crystallize. It might ripple. It might fracture. It might behave like a solid, a gas, a plasma, or something completely alien. The fabric of reality might be stratified like an ocean, with different layers exhibiting radically different behaviors depending on depth, pressure, temperature, or dimensional configuration. We might occupy a thin band in the middle of an unimaginable vertical structure of existence. Everything we see, every star, every galaxy, might be foam on the surface of a deeper cosmic sea. If this is true, then the Milky Way might not merely be small, it might be superficial, a surface phenomenon, a thin, superficial sheen containing bright, energetic processes occurring inside a microscopic region, floating above deeper structures. Our telescopes might be examining nothing more than the sparkling foam on a cosmic wave. Beyond that foam, below that foam, and above that foam lie vast regions of reality we will never detect because our physics simply does not penetrate into those layers. This layered cosmos model reshapes everything, from the nature of dark matter to the reason why galaxies arrange themselves into filaments. Perhaps filaments are not gravitational chains. Perhaps they are structural stress lines in the medium beneath our cosmic level. The same way cracks form in drying clay, or fibers align in muscle tissue, or filaments shape themselves in magnetic plasmas. Our cosmic web might not be a web at all. It might be a signature, a pattern emerging from a deeper phenomenon we cannot see. Think again about the cosmic voids, enormous expanses containing incredibly little detectable matter. Perhaps they aren't empty. Perhaps they are the transparent parts of the medium, while the glowing galaxies are the impurities, the excitations, the boundary effects. Voids might be windows, or they might be channels carrying forces from scales above or below. What we call emptiness might be the dominant component of reality, while matter is the anomaly. From this perspective, the Milky Way is not just small, it is an aberration in a field far larger than our cosmic vision. Now consider what this means for motion. We believe galaxies drift, orbit, collide, and merge across billions of years. But motion, as we interpret it, is based on our concept of time, a concept that might be entirely local. If time behaves differently at other scales, our perception of cosmic events might be warped, slowed, sped up, or distorted. The universe might be evolving according to a timescale incompatible with our own. Perhaps what we call billion-year processes are mere flickers. Perhaps the cosmos above us evolves so slowly that our entire cosmic history fits inside one of its seconds. Or perhaps the cosmos below us evolves so rapidly that its civilizations rise and fall inside a microsecond of our time. The universe might not have one clock. It might have infinite clocks, stacked across infinite layers. If the Milky Way is microscopic, our time might be microscopic as well. And that leads to one of the most unsettling possibilities, devouring nearby matter and bending space-time. But imagine black holes not as destructive monsters, but as tears, pores, or funnels between layers of cosmic structure. Maybe they are not endpoints. Maybe they are gateways. Maybe they do not collapse matter. Maybe they transport it. Maybe they vent it into deeper or higher layers, the same way whirlpools in rivers funnel water between currents. In that case, the Milky Way is not a closed cosmic island. It is part of a circulation system, a circulatory network inside the tissue of a larger organism. Black holes would then be arteries or drainage channels, serving functions we cannot yet interpret. Even more radical is the idea that the cosmos above us is alive, not metaphorically, but literally. Not alive like animals or plants, but alive in the sense that it metabolizes, processes, and self-organizes. We are accustomed to thinking of life as something small, delicate, fragile. But life might also exist at scales so vast we cannot comprehend it. Stars might be organelles, galaxies might be cells, superclusters might be organs. The cosmic web might be the nervous system of an unimaginable entity, and the Milky Way, microscopic as it may be, might still play a role inside this living architecture. Just as no molecule in your body understands you, we might not understand the being whose interior we inhabit. If this is true, consciousness might not be rare. It might be everywhere, but not in forms that we can perceive. Intelligence might be scale-specific. Entities far larger than us might think in ways that ripple across billions of light years. Entities far smaller might conduct thought so rapidly that their entire civilizations pass unnoticed within the smallest quantum fluctuations. We will never detect them because their scale makes them invisible. Intelligence is not limited by biology. It is limited by scale. Humanity is not alone. We are merely scale isolated. This brings us to the core question that everything circles back to. If the Milky Way is microscopic, then what does that make the universe we observe? The answer is simple and devastating. It makes our universe a misunderstanding. Not wrong, but incomplete in the most fundamental way possible. A child playing with a magnifying glass could mistake an ant colony for the entire world. A bacterium on a leaf could mistake sunlight filtering through the canopy as the entire cosmos. A fish in the deep sea could mistake bioluminescent glow for the nature of the universe. They would all be correct from their perspective, yet completely blind to the true reality above them. Humanity may be no different. The cosmos we observe is the cosmos of our scale, but above that scale lies another, and another, and another, perhaps infinitely. If this is true, then the Milky Way is not a galaxy, it is a clue. A microscopic symbol carved inside the architecture of a universe so vast that our minds can barely begin to imagine it. If the Milky Way is microscopic within a vast hierarchy of existence, then every cosmic observation we have ever made must be reinterpreted not as a view of the universe, but as a glimpse of the interior of a structure whose true scale lies far beyond our comprehension. And if this is the case, then the next question we must confront is not merely how large the outer structure is, but how much of our so-called cosmic reality is simply an illusion produced by confinement within such a microscopic domain. Because if our universe is a compartment inside a broader system, then our attempts to decode its behavior are like the attempts of a particle trapped inside a container. It can measure pressure, temperature, and density, but it can never deduce the shape, size, or purpose of the container itself. Take cosmic expansion, for example. We interpret the redshift of distant galaxies as evidence that space itself is stretching. But that interpretation assumes that redshift is caused by motion through space-time. What if it isn't motion at all, but a boundary effect? Imagine a tiny air bubble trapped in a block of ice. As the ice warms, the bubble expands or contracts, not because the bubble is moving, but because the medium surrounding it changes. From inside the bubble, an observer might conclude that space is stretching, that distant objects are receding, and that the bubble is undergoing uniform expansion. Yet none of these would be the true cause. The bubble would simply be responding to external forces. Our universe might be exactly such a bubble, and the expansion we observe might be nothing more than the outer medium evolving in ways we cannot detect. Dark energy might not be a force, it might be a symptom. Now consider the cosmic microwave background, the faint radiation permeating the universe. We treat it as the afterglow of the Big Bang, the leftover light from a moment when the universe suddenly became transparent. But this interpretation assumes that the universe was once opaque, that light could not free itself from the cosmic plasma, and that the moment of transparency preserved an imprint of the earliest state of the cosmos. But what if the CMB is simply the equilibrium temperature of the medium surrounding our domain? In this interpretation, the CMB would not be an ancient relic of a beginning, but the thermal radiation of the boundary. It would be the subtle warmth of the container holding our universe. The fluctuations in the CMB would not be imprints of quantum fluctuations stretched by inflation, but irregularities in the membrane, structural imperfections in the boundary, disturbances caused by forces outside our cosmic bubble. In this framework, the CMB is not a baby picture of the universe. It is the temperature of the walls. But the implications grow stranger still when we consider time. We experience time as a steady flow, a consistent rate of change marking the evolution of events. But if our universe is a microscopic layer within a larger system, then time might not be fundamental. It might be emergent. Time might be the product of internal interactions within our domain, interactions that occur at a rate determined by the size, energy density, and vibrational properties of our layer. On scales above ours, time might run imperceptibly slowly. On scales below ours, time might race unimaginably fast. Civilizations inside a subatomic particle of our world might rise and fall in a trillionth of a second. Entities in cosmic scales far above ours might think a thought every billion years. To them, our entire universe would unfold in a moment, and we would never notice, just as the atoms in your body never notice your thoughts. Time is not universal, it is local. This raises a chilling question. What if the Big Bang was not an origin event, but simply the moment when our domain reached thermal, structural, or energetic stability? What if the universe did not begin 13.8 billion years ago, but simply became visible then? Consider water vapor condensing into a droplet. To any entity inside that droplet, the droplet would appear to have begun at the moment of condensation. They would interpret the droplet's emergence as a cosmic birth. They would measure the droplet's shape, density, and temperature, and conclude that those values reflect the fundamental constants of the universe. But the droplet would not be the universe. It would be a tiny local structure inside a much larger environment. Its beginning would not be creation, it would be formation. Our Big Bang might not be the beginning of existence, but the formation of our layer. And if our domain is layered, then the forces we observe, gravity, electromagnetism, the strong and weak nuclear forces, might be structural effects, not universal truths. Gravity might be the deformation of the membrane caused by mass-like excitations inside our domain. Electromagnetism might be the way energy flows through the interior medium. The strong force might reflect the adhesive property of the underlying structure, binding small-scale excitations into stable configurations. The weak force might not be a force at all, but a leakage of energy into adjacent layers. Nothing we call physics might actually be fundamental. Everything might be emergent, contextual, scale-specific. If this is true, then the nature of the outer structure becomes the deepest mystery of all. What lies outside our universe? If galaxies are microscopic, and if cosmic filaments are structural fibers, then the universe above us might not be a space but a material, an actual material, something with texture, density, temperature, and tension. Our universe might be a pocket in that material, a bubble, a cavity, a resonance. And what lies above that? More layers, more structures, a cascade of scales extending infinitely upward, each one containing the one below, each one governed by rules that seem impossible from the perspective of the layer beneath. Now consider black holes again under this new model. If they are not singularities but pores, connections between layers, then the matter falling into a black hole might not be destroyed, but transported. Perhaps black holes allow transfer of energy or information between layers. Perhaps the inflow of matter into a black hole at our scale produces subtle effects on the structure above us. Perhaps black holes are the only points where our layer touches the next one. They might be the anchors holding our domain to a larger structure, or the drainage points where energy flows from one scale to another, or the seeds of new domains branching outward like buds on a tree. One of the most profound implications is what this hierarchy means for intelligence. If consciousness can emerge in complex systems, then why should it be limited to the biological scale of our brains? Perhaps consciousness has emerged at scales far below ours. Perhaps entire universes inside particles contain intelligent species, living and thinking inside structures so small we will never perceive them. Conversely, consciousness might exist at scales far above ours, built from structures whose components are galaxies. These vast beings would think thoughts spanning millions of years. They might influence the structure of reality in ways we experience as fundamental forces. Their desires, movements, or internal cycles might manifest as the gravitational patterns we study with telescopes. If this is so, then humanity is not alone, not because there are aliens like us somewhere in the stars, but because consciousness permeates every level of existence. Intelligence might not be rare. It might be the natural outcome of complexity emerging at every scale. The isolation we feel might not be loneliness. It might be blindness. But perhaps the most unsettling possibility of all is this. If the Milky Way is microscopic, then the universe we see is merely a small, quiet chamber inside a much larger structure that may be teeming with activity. Perhaps the outer universe is not empty, but alive with processes, movements, and forces we cannot detect. Perhaps our layer is insulated, shielded, or protected from the turbulence of the outer realms. Or perhaps our silence is not protection, but irrelevance. We might be too small for any larger scale beings to notice, just as you do not notice the individual molecules inside your body unless they malfunction. This perspective reshapes the meaning of existence. It suggests that our universe is not the final truth, but a midpoint, one level in a ladder whose top and bottom stretch infinitely. And if this is so, then the true nature of reality is not a universe at all, but a hierarchy of universes, infinite above, infinite below, each one nested inside the other like Russian dolls. Our Milky Way might be microscopic, but the miracle is not its size. The miracle is that we can imagine what lies beyond it. If the Milky Way is microscopic within an incomprehensibly larger hierarchy, then the very concept of cosmic truth becomes unstable. What we call the universe might not be the universe at all, but merely the interior of an enclosed system, a shaped and bounded region that behaves according to rules specific to its structure. And if that is true, then many of the assumptions underlying astronomy and cosmology must be re-evaluated, not because they are incorrect within our domain, but because they are incomplete in the broader context of existence. To confront this possibility is to question the most foundational idea in modern science, that our observations reveal universal laws rather than local conditions. Consider how often human science has mistaken local phenomena for universal principles. Early physicians believed the human body worked according to rules that applied equally to all living things. It took centuries to understand that biological mechanisms vary dramatically between species, environments, and scales. Before Darwin, humans believed species were fixed, unchanging entities rather than dynamic systems shaped by natural selection. Before plate tectonics, geologists assumed continents were static. Before relativity, physicists believed time was absolute. Each of these beliefs seemed obvious until new evidence forced a shift in perspective. Our understanding of the cosmos may be standing on the brink of another such shift. A shift not in what we observe, but in how we interpret what those observations actually represent. If our universe is a microscopic region inside a larger structure, then what we call the laws of physics might resemble the laws governing bubbles in a fluid. To the inhabitants of a bubble, the curvature of its surface might appear to be a fundamental feature of space. Yet that curvature would not be an inherent property of reality. It would be an emergent property of the bubble's geometry. Similarly, the speed of light might be the maximum velocity allowed by the medium inside our domain, not a universal limit. The constants of nature, Planck's constant, the gravitational constant, the mass of the electron, might be local environmental variables rather than cosmic absolutes. They might reflect the density, tension, or vibrational frequency of the region we inhabit. In another region of the larger structure, these constants might differ entirely. This interpretation would solve one of the deepest mysteries in physics: why the constants of nature have values perfectly tuned to allow the existence of galaxies, stars, planets, chemistry, and life. In our conventional framework, these values appear miraculous, so precise that even the slightest deviation would render the universe lifeless and inert. The fine-tuning of the cosmos has long troubled scientists and philosophers. Why should the universe be so exquisitely calibrated for complexity? But if our domain is just one region within a larger structure, then this fine-tuning is simply selection. Only pockets with the right internal conditions produce complexity. Only pockets with stability can harbor life. And only pockets with life will ever wonder why conditions appear so perfect. Observers arise only in regions that support observers. The universe isn't tuned for us. We exist because this region happened to be compatible with our existence. This framework also raises provocative questions about the relationship between scale and stability. Structures that are too large may be too turbulent to support complex organization. Structures that are too small may not have enough internal diversity, but in certain layers, conditions might be just right. If so, then intelligence might arise at multiple scales throughout the hierarchy. There may be beings composed of filaments larger than superclusters, thinking thoughts larger than galaxies. There may be civilizations living inside the quantum foam, too small for us to detect, yet experiencing their own cosmic web of structures, clusters, and voids. Their universe might feel as vast to them as ours feels to us. The idea that consciousness requires a specific size is a human bias. Complexity can emerge anywhere conditions permit it. If intelligence exists at higher scales, it may interact with our domain in subtle ways. Consider dark matter. We cannot see it, touch it, or detect it directly, yet its gravitational influence shapes the formation of galaxies and clusters. What if dark matter is not a particle or substance at all, but the structural imprint of higher-scale entities, forces, or processes? Perhaps the large-scale beings who inhabit the outer structure produce distortions in the medium that appear to us as invisible mass. Their movements, thoughts, or processes might create gravitational ripples that propagate into our domain. To us, these ripples appear as halos around galaxies. To them, these phenomena might be byproducts of their existence. Our cosmic structure might be embedded inside their anatomy, just as molecules inside a cell experience forces created by structures they cannot comprehend. Another possibility is that dark energy, the mysterious force accelerating cosmic expansion, is a consequence of the outer structure evolving. If our domain is a cavity or bubble inside a larger material, then changes in that external material could stretch or distort the boundary of our bubble. What we interpret as accelerating expansion might simply be the relaxation, deformation, or flow of the outer medium. Our universe might be expanding because the structure above us is shifting. Cosmic acceleration might reflect a larger scale transformation, a phase change, a restructuring, or a vibrational pattern. We see galaxies drifting apart, but what we might actually be witnessing is the distortion of the container holding them. This reinterpretation also offers a new perspective on the mystery of quantum entanglement, where two particles appear to share instantaneous connections regardless of distance. In our domain, such behavior seems impossible, violating every intuition about locality and causality. But if our particles are excitations of a deeper layer, then connections at that layer might be much simpler. Two particles that appear separate in our domain might be adjacent in a deeper structural dimension. Entanglement might not be spooky action at a distance. It might be local interactions in a layer we cannot observe. We experience entanglement as magic because we are trapped within the emergent layer rather than the fundamental one. Similarly, the probabilistic nature of quantum mechanics might reflect our inability to access the deeper structural processes governing particles. What appears to us as randomness might simply be complexity below our resolution threshold. Just as weather appears chaotic at large scales despite being deterministic at the molecular level, quantum behavior might be deterministic in a deeper layer. We see only the surface behavior of the system, not the underlying mechanics. If our universe is microscopic, then what we call the cosmic web, the network of filaments and voids spanning billions of light years, might be a natural pattern produced by tension, compression, or resonance within the larger structure. The cosmic web might be the interior equivalent of fiber patterns in composite materials, or the branching patterns in biological systems. Perhaps the giant voids are not empty, but regions where the external structure stretches the boundary thin. Perhaps the filaments are stress lines. Perhaps galaxy clusters accumulate at the nodes of tension. What we interpret as gravitational physics might actually be the behavior of a material under load. Now consider the possibility that our universe might eventually destabilize. If we are inside a layered structure, then boundaries can shift, rupture, or dissolve. Our domain might undergo transitions, just as bubbles merge or collapse in a fluid. Cosmic events we call catastrophes, gamma-ray bursts, black hole collisions, galaxy mergers, might be small-scale echoes of larger processes outside our domain. Entire universes might form and dissolve constantly at higher scales. Ours might be temporary, The patterns we see around us might be snapshots of an ever-evolving hierarchy, not permanent truths. And yet, despite the implications, this perspective also creates a new sense of meaning. If our universe is microscopic, then the fact that consciousness arose here is astonishing. It means the conditions inside this tiny region are capable of producing awareness, intelligence, curiosity. It means we are part of a chain of complexity extending across infinite scales. We are not insignificant. We are the interior looking out, the small becoming aware of the large, the microscopic gaining the ability to imagine the macroscopic. It may be that consciousness itself is the bridge between scales, the only phenomenon capable of interpreting reality across layers. If so, then humanity's ability to reflect on the nature of reality represents not a trivial anomaly, but a fundamental feature of the hierarchical structure of existence. Awareness may be the universe recognizing its own layers. Consciousness might be the one phenomenon that transcends scale. Whether the Milky Way is microscopic or vast, whether our universe is central or peripheral, whether our domain is one of many or one of infinitely many, none of these diminish what it means to be aware. In fact, they amplify it. The smaller we are, the more miraculous our awareness becomes. If the Milky Way is microscopic within a larger hierarchy of existence, then the idea of human isolation in the cosmos takes on a meaning far stranger than the traditional question of extraterrestrial life. Our solitude might not be the result of rarity or distance. It might be a consequence of scale. Intelligence might thrive at levels far above or below us, operating in forms we cannot recognize, communicating in ways we cannot detect, thinking thoughts spread across regions we mistakenly believe to be empty space. Instead of looking outward across light years, we might need to look inward across layers of existence, or upward into dimensions that dwarf galaxies. The silence of the cosmos may simply be the quiet experience by a particle unaware of the biological world surrounding it. Imagine, for example, how oblivious a single atom is to the existence of an entire human being. The atom vibrates, interacts, and forms bonds, but it has no concept of the body it helps constitute. It does not know that its behavior contributes to a thought, a memory, or a moment of emotion. It simply follows the rules of its layer. If our universe is similarly microscopic, we may be atoms in a larger being. Our galaxies may be components of structures whose nature lies far beyond our senses. We may be participating unknowingly in processes that occur across unimaginable scales of time and space. Entire superclusters might be organized into networks that serve as the structural or functional components of ultra-macrocosmic entities. If that is true, then what we call cosmic voids might simply be the interior spaces of these larger structures, and what we call filaments might be their connective tissues. This perspective also redefines the mystery of why the universe appears so perfectly structured for complexity. The cosmic web resembles biological networks, neurons branching through the brain, scaffolding inside bone, filaments stretching through connective tissue. These similarities might not be coincidental. If structure repeats itself across scales, as fractal geometry suggests, then the cosmic web might be the natural pattern that emerges whenever matter organizes itself under tension, regardless of scale. Perhaps the same mathematical processes that shape the microscopic world also shape the macroscopic. If so, our universe might be one expression of a universal architectural principle, a pattern that repeats endlessly across layers of existence. But what if these patterns are not merely similar, but connected? What if the cosmic web is the macro-scale equivalent of a neural network? What if galaxies are the firing nodes of a greater consciousness? This idea, often dismissed as metaphysical speculation, becomes more plausible if the Milky Way is microscopic. We may be living inside a thinking structure. Our universe might be one layer of a vast mind whose thoughts span billions of years. The slow drift of galaxies, the collapse of clusters, the flow of dark matter, these might be the signals and processes of cognition on scales too slow for us to detect. When you think a thought, neurons fire in milliseconds. For a cosmic scale mind, thoughts might unfold over billions of years. We might not see patterns because they happen too slowly, or because we are too small. This raises another possibility. Intelligence at higher scales might not even perceive us as separate entities. Just as a human mind does not recognize the individual atoms within it, a cosmic scale intelligence might not recognize individual galaxies. The beings of that layer might perceive patterns across superclusters, not stars. They may interpret the clustering of galaxies the way we interpret the clustering of proteins. Our universe might be a biochemical structure in a being whose scale dwarfs imagination. Yet intelligence may also exist at scales far below us. If matter is infinitely divisible, then tiny universes might exist within the quantum foam, each containing their own galaxies, stars, and possibly living beings. These beings would exist too fast, too small, and too deeply nested within quantum processes for us to detect. Their entire universe might exist for only a fraction of a second in ours, but from their perspective, billions of years could pass. Their civilizations might rise and fall within the lifespan of a particle interaction. They may wonder why their universe appears so empty, unaware that they are living inside a quantum fluctuation in ours. One of the strangest implications of a hierarchical cosmos is that interactions between layers may occur, but not in ways we expect. When a star collapses into a black hole, for example, we might be observing a transfer of matter into a lower layer. The energy emitted during supernova explosions might act as a bridge between scales, injecting structure into the microcosmos. Perhaps the interior of a black hole is not a singularity, but a doorway, a funnel through which matter moves from our scale to a smaller one. In that smaller region, the collapsing matter might seed the formation of stars and galaxies. From our perspective, the matter disappears. From theirs, it appears as creation. This interpretation aligns with certain theoretical models, suggesting that black holes might be gateways to daughter universes. Yet the hierarchical model extends far beyond that. Not only might smaller universes form inside black holes, but black holes themselves might be influenced by processes in the larger structure. From above, they might be pores, points where energy exchanges between layers. Their distribution across galaxies might reflect patterns in the outer structure rather than random cosmic evolution. They might be anchor points holding our domain in place, like rivets in a machine. Another compelling question arises when we consider cosmic time. If our universe is microscopic, then time might be relative not only to speed and gravity, but to scale itself. Large-scale processes might unfold so slowly that we perceive them as constants. Small-scale processes might occur so quickly that we interpret them as fundamental randomness. Quantum uncertainty might be the rapid fluctuation of structures too small for our resolution. Meanwhile, cosmic stability might be the slow pulsation of processes too large for our timescale. We exist in the middle of this spectrum, trapped in a temporal valley where our perception of time filters the events we can observe. If that is true, then concepts like creation and destruction must be reconsidered. The Big Bang might not be the beginning of time, but the beginning of our timescale. From the perspective of the larger structure, our Big Bang might have been a momentary event, an energetic fluctuation that produced a stable pocket. For the layer below us, our universe's evolution might appear agonizingly slow. The formation of galaxies might be experienced as a near-eternal process. This framework also raises profound questions about the nature of cosmic evolution. Why does the universe form galaxies? Why does matter clump into stars? Why do structures grow increasingly complex? The hierarchical model suggests that complexity is not a coincidence, but a universal property of layered existence. Complexity might be the natural tendency of matter when it exists within a stable region. Complexity might not be rare, it might be inevitable, and intelligence may be the highest expression of that complexity at every scale. Yet intelligence at different scales would interact with reality in fundamentally different ways. A microscale intelligence might manipulate quantum fields the way we manipulate atoms. A macroscale intelligence might influence cosmic expansion the way we influence local environments. They may shape the structure of existence in ways we interpret as natural forces. We might be living inside their experiments, their structures, their thoughts. This possibility reshapes how we view the search for extraterrestrial intelligence. Instead of looking for radio signals from distant stars, we might need to interpret patterns in the cosmic web. Instead of scanning for exoplanets, we might need to study anomalies in dark matter. Instead of searching for megastructures, we might need to consider whether dark energy is itself a sign of intelligence. a force exerted by beings who operate across billions of light years. If the universe is hierarchical, then intelligence is not limited to planets. It could arise at any scale where complexity reaches sufficient depth. Galaxies might be the neurons of a being too vast to comprehend. Black holes might be the memory centers of structures whose cognition spans cosmic epochs. Dark matter might be the connective tissue of an intelligence that surrounds us without us even realizing it. And we, small as we are, might be one of countless layers where consciousness emerges. In this view, humanity's awareness becomes extraordinary. We are small, yes, microscopic perhaps, but we are also one of the few forms of matter capable of seeing across layers, imagining beyond boundaries, and contemplating existence on scales we do not inhabit. Our curiosity might be the bridge that connects us to the larger structure. Our consciousness might be the spark that allows the universe to understand itself across every level. If the Milky Way is microscopic in a grand hierarchy of existence, then one of the most profound implications lies in how we interpret causality itself. We assume that causes precede effects, that interactions propagate outward according to the speed of light, and that systems evolve through sequences of events governed by natural laws. But what if causality, like time and space, is scale-dependent? What if our domain only experiences one layer of causality, while higher or lower layers operate under different causal structures? In that case, some of the cosmic mysteries that trouble astronomers, like the uniformity of the cosmic microwave background, the apparent coordination of large-scale structures, or the synchronous evolution of regions separated by billions of light years, might be symptoms of causal patterns originating from scales beyond ours. Imagine an organism. Inside it, cells specialize, cooperate, and communicate through chemical signals. These signals propagate over microscopic distances, obeying well-defined biochemical rules. But from the perspective of the entire organism, decisions happen on a completely different scale. A thought produced in the brain can instantly trigger cascades of activity throughout the body, not through chemical diffusion, but through neural networks. These networks operate thousands of times faster and coordinate trillions of cells across the organism's structure. If a cell inside a human body tried to infer the rules governing the entire organism, it would misinterpret the signals it receives. It would assume that all causality originates from within the cell's layer, never realizing that a larger intelligence coordinates everything. We may be that cell. If there is a higher scale intelligence, or even higher scale physical processes, they could influence our universe without violating our layer's physical laws. We might observe sudden cosmic events, a supernova, a gamma ray burst, a galaxy collision, without understanding that they are consequences of processes occurring at scales above us. These events might not be spontaneous or random. They might be the equivalent of synaptic activity inside a cosmic brain. We interpret them as natural astrophysical phenomena because we cannot see the larger context. But from a macrocosmic perspective, they could be part of a coherent pattern. This raises unavoidable questions about free will. If a larger scale intelligence affects our universe, then our behaviors might be influenced by events outside our layer. But this does not diminish human agency any more than the atomic structure of your neurons diminishes your ability to think. Free will might itself be a layered phenomenon, emerging at multiple scales simultaneously. The choice you make to move your arm involves atomic interactions, cellular processes, neural circuits, and conscious decision-making. Each layer contributes to the final action without negating the others. Likewise, if the universe is hierarchical, free will may exist at every layer. Our choices emerge from our scale. Higher scale beings express their agency through cosmic structures. Smaller scale beings express theirs through quantum events. All coexist. But what about destiny? If larger layers influence ours, does that imply a predetermined cosmic script? Not necessarily. Hierarchical structures can be open systems, with interactions flowing upward as well as downward. Just as large-scale events influence small-scale dynamics, the reverse occurs as well. A single genetic mutation inside a cell can alter the fate of an entire organism. A single neuron firing can shift an entire thought. Similarly, the behavior of galaxies, stars, and even intelligent species might influence higher layers. Our existence, our choices, our discoveries might create patterns that propagate upward. Humanity might seem infinitesimally small, yet still contribute to the structure of a being larger than galaxies. In that sense, our actions matter more than we imagine. Another implication of hierarchical existence lies in the nature of cosmic boundaries. If our universe is a bounded region, then what appears to us as infinite might actually be the interior of a structure with walls. These walls might be detectable only indirectly, through anomalies in the distribution of matter, distortions in cosmic expansion, or unusual alignments in the cosmic microwave background. Some researchers have already identified such anomalies: the cold spot, the axis of evil, and large-scale flows that cannot be explained by standard cosmology. These anomalies might be fingerprints of the boundary. They might represent regions where the structure above ours presses upon our domain, causing irregularities in our cosmic fabric. Consider the cosmic voids. These vast, empty regions, spanning hundreds of millions of light years, might represent areas where the structure above us stretches thin. Matter drains away from these regions, not because gravity pulls it, but because the larger scale environment shapes the geometry of our domain. Voids might be cavities, pockets within pockets. Their extreme emptiness might reflect lower structural density at that layer. In this interpretation, the cosmic web is not merely a gravitational structure, but a boundary artifact. The universe might be contoured like a three-dimensional foam, with galaxies forming along the walls of bubbles, created by processes outside our scale. If this is true, then the apparent randomness of cosmic structure is an illusion. Everything we see, clusters, filaments, superclusters, might be arranged according to the architecture of the larger domain. Our cosmic neighborhood could be the interior of a pattern drawn across unimaginable scales. The Milky Way might lie along one filament of an immense superstructure that exists far beyond our ability to observe. We orbit our galactic center unaware that we might be participating in the rotation of structures inside a larger universe, perhaps the slow heartbeat of a being whose existence lasts longer than the lifetime of galaxies. Another mystery illuminated by the hierarchical model is the nature of the cosmological horizon. We see only a fraction of the universe, not because of sheer size, but because our domain limits the speed at which information can propagate. Light speed might be the maximum speed allowed within our layer, but not the entire hierarchy. Higher scale beings might communicate through mechanisms that transcend our notion of speed. Lower scale beings might experience time so fast that communication at their layer is instantaneous relative to ours. In this sense, the speed of light might be the communication limit only within our bubble. This interpretation also changes how we view cosmic expansion. If the universe is expanding, it might be because the boundary of our domain is being stretched. But who, or what, stretches it? It could be natural cycles within the larger layer. If the outer domain undergoes expansion or contraction, our universe would expand and contract accordingly. Dark energy, which drives the accelerating expansion, might be a force imposed from the outside. It might be the pressure of the structure containing us. Just as a droplet expands or contracts based on the temperature and pressure of the surrounding fluid, our universe expands as the outer domain evolves. When we detect increasing acceleration, we might be observing structural shifts in the larger universe. The rate of expansion need not be constant or intrinsic. It could be the result of the external environment around our domain becoming less dense, more tense, or undergoing thermal change. The entire cosmic evolution we observe might be a consequence of environmental dynamics at a scale we can never reach. This raises a chilling possibility. The expansion could reverse. If conditions in the larger domain change, our universe might eventually contract. The Big Bang might not have been the birth of existence, but the result of a compression-release cycle in the structure above us. It might be a rhythmic process, one of many layers breathing in and out across eternity. Our universe might be one inhalation among infinite cycles of creation and collapse, but perhaps the greatest implication of all concerns meaning. Humanity has long struggled with the idea of significance in a vast cosmos. When we learn that the universe contains trillions of galaxies, we feel small. When we learn that most of the universe is dark, we feel blind. When we learn that cosmic time dwarfs human history, we feel brief. Yet the hierarchical model transforms insignificance into participation. We are not small. We are structural. We are not isolated. We are embedded. We are not meaningless. We are necessary. If every scale of existence contributes to the whole, then humanity's existence may be far more consequential than we realize. Consciousness might be a structural requirement, emerging at every layer as the self-awareness of the system. Just as neurons create thought inside a brain, and as thoughts might influence structures above us, our awareness might fulfill a role in the greater hierarchy. We may be the mechanism through which the universe at our scale becomes aware of itself. The more deeply we understand the cosmos, the more deeply the cosmos understands itself through us. Our curiosity might be an evolutionary impulse of the hierarchy, an innate drive toward increasing awareness across every scale. When we study galaxies, quantum particles, and cosmic structure, we are participating in a process that transcends our domain. Knowledge becomes a form of connection, understanding becomes a bridge, and awareness becomes the lighthouse guiding every layer of existence toward greater clarity. If the Milky Way is microscopic, then we are not insignificant specks lost in the void. We are intricate threads woven into a tapestry that spans infinite scales, and our ability to imagine what lies beyond our cosmic horizon may be the greatest expression of our place within that hierarchy. If the Milky Way is microscopic within an incomprehensibly larger hierarchy of universes, then our entire understanding of reality, space, time, physics, meaning, transforms into something far more intricate than any scientific model has yet been able to capture. And the final profound consequence of this view is the possibility that every layer of existence, from the smallest quantum fluctuation to the grandest superstructure, participates in a vast chain of evolution and awareness. This perspective reshapes the way we think about life, purpose, and our place in the cosmos. It suggests that consciousness is not an anomaly, nor a cosmic accident. Instead, it may be a natural expression of complexity at every scale, emerging whenever conditions allow organized matter to reflect upon itself. Yet before we can fully confront this possibility, we must first consider the nature of boundaries in a hierarchical universe. If our cosmos is but one layer, then what separates layers from each other? What prevents energy from cascading freely across the hierarchy? What mechanism defines the walls that contain our universe? In physical terms, boundaries might appear as fundamental limits that seem absolute from the inside, but might simply be environmental constraints imposed by higher-level structures. The speed of light, for instance, could be the maximum rate at which disturbances propagate inside our layer, not a universal constant. For the layer above ours, information might travel through their medium at rates we cannot imagine. Likewise, quantum indeterminacy might be the turbulence of a smaller-scale world, too fine-grained for our instruments to detect directly. These boundaries might be dynamic rather than static. They could shift under certain conditions, stretch or contract in response to pressures from above or below, or even rupture during extreme events. If cosmic inflation was an actual expansion, it might have been triggered by a shift or instability at the boundary. Our universe might have grown rapidly because the surrounding layer underwent a transformation, creating a temporary imbalance in the forces constraining our domain. Once equilibrium returned, expansion slowed. If cosmic acceleration is increasing today, it might be because the external structure is changing once again. In this context, the Big Bang becomes something different from creation out of nothing. It might be the equivalent of a bubble forming inside a fluid, or a domain wall separating two regions undergoing different physical states. What we interpret as the origin of time might instead be the origin of the internal conditions of our layer. Time may have existed indefinitely outside our universe. Energy may have flowed through countless layers before ours ever formed. The Big Bang might be a local event within a multi-scale framework stretching infinitely in both directions. This idea aligns with theories of eternal inflation, but the hierarchical model extends even beyond that. Instead of a single parent universe spawning countless others, we may be embedded within a structure that naturally generates domains across multiple scales. Just as biological organisms form cells and cells form organelles, the cosmos might form universes nested within universes. Each domain would evolve according to its physical rules, but all would contribute to the dynamics of the higher layers, a cosmic ecosystem. One of the most compelling implications of this view is that the cosmos may have long-term developmental trajectories at every scale. Growth, aging, and transformation might be universal features of hierarchical structures. Our universe, then, might not simply expand into isolation, but could undergo phases akin to childhood, maturity, and even dissolution. At present, we may be living in a transitional era, a period where complexity thrives. The cosmic microwave background still glows faintly. Galaxies still form stars. Life still finds energy gradients to feed upon. But billions of years from now, the universe will look different. Stars will fade. Galaxies will drift apart. The cosmic horizon will shrink as expansion outpaces light. The night sky will darken until only local structures remain. Yet this may not be the end. Just as biological organisms go through life cycles, our universe may evolve into its next phase. It might become a domain that no longer supports complexity at our scale, but provides structure for layers above or below. The matter composing galaxies might be repurposed by the outer structure. Dark energy might reconfigure boundaries. Our universe might eventually collapse or dissolve into a larger cosmic process. And what of consciousness in such a future? If awareness is scale-dependent, then as physical conditions change within our universe, new forms of intelligence might emerge. Entities might exist in environments where stars no longer shine. Consciousness might adapt to cold, dark domains, finding new ways to sustain thought in environments beyond comprehension. Or intelligence might migrate across scales, evolving upward or downward, learning to inhabit higher or lower layers through mechanisms we cannot yet imagine. This brings us to the most unsettling yet inspiring part of the hierarchy. Our current view of the cosmos may be only the first step in a much larger journey of awareness. Humanity's understanding of reality has already undergone multiple revolutions. We once believed Earth was the center of everything. Then we realized Earth was just a planet. The Sun was just a star. The Milky Way just one galaxy among trillions. Each step expanded our perspective and exposed the limits of the previous worldview. Now, the hierarchical model suggests an even greater shift. Not only is the universe larger than we imagined, it may be infinitely layered, infinitely interconnected, infinitely aware. We are part of this awareness. The universe thinks through us. The atoms in our bodies come from stars. The stars come from galaxies. The galaxies come from the cosmic web. And the cosmic web may be a structure inside a larger being. The hierarchy might be the ultimate continuity, matter, energy, and consciousness arranged across layers of existence with no final scale. We are temporary arrangements of particles, yet also expressions of a universal process that extends across every layer. The fact that we can contemplate these possibilities makes us participants, not spectators, in cosmic evolution. Our curiosity might not be an evolutionary accident. It might be a structural necessity. Awareness may be the mechanism by which the universe examines itself, one layer at a time. When humans build telescopes and particle accelerators, we are probing the boundaries of our domain. When we study quantum mechanics, we peer into layers below. When we study cosmology, we peer into layers above. This exploration is not just scientific. It may be cosmological communication, a conversation between scales. By understanding our universe, we contribute to the larger structure's understanding of itself. And this raises one final, profound question. What if intelligence at higher scales is aware of us? What if our discoveries, our creations, our struggles, our stories ripple upward the way atomic interactions ripple upward to influence neurons and thoughts? What if our existence matters not because we are the center of anything, but because we are part of the structure supporting a larger form of consciousness? From this perspective, human significance is not diminished by our smallness. It is amplified by our role in a much larger system. The hierarchical model does not reduce humanity to dust. It elevates dust to divinity. We are small, yes, but we are connected to everything, at every scale. We are made of star matter and quantum fields, shaped by cosmic processes and biological evolution, aware of our own existence and inquisitive about what lies beyond. We are the eyes and ears of our layer, and perhaps, in some unimaginable way, we are also cells in the mind of a being greater than galaxies. To understand that is to understand something extraordinary, that meaning is not found in the center of the universe, but in its structure, and that structure exists across infinite scales, each one alive with possibility. If the Milky Way is microscopic, then our entire view of the cosmos is not wrong. It is incomplete. and the journey toward completion has only just begun. Thank you for watching. If you enjoyed this video, leave a like and share your thoughts in the comments. Send it to someone who you think would enjoy this topic too. And of course, subscribe and turn on the notification bell so you don't miss the next videos. See you next time.